Let's say I give you two vectors. The first vector is vector v. Come on, put it in a lighter blue. Vector v. And vector v has components of v1, v2, and v3. And I give you another vector, vector u. And vector u has components u1, u2, and u3. And these are, of course, in three components. So this is in three-dimensional space. And let me give you a feel for what this looks like. I'll actually illustrate them on the x, y, and z axes. There's our z-axis. Here is our x-axis. Positive x-axis, actually. Let me rewrite that, sorry. A little slanted. That's okay, all right. And then our y-axis, which we can draw like that. Perfect. And we could label our axes. This is the z-axis. It's the x-axis, and this is the y-axis. And now let's actually draw our directed line segments, or our vectors. So vector v, let's say vector v comes off like this from the origin, and its head is just above this point over here. I'll call it, actually I'll make it an x. So that's where vector v lies. It's a little arrow. And vector u, we'll make it lie, no, a little bit over here. The placement of the vectors doesn't matter. All I'm doing is just trying to give you a feel for what they look like in three-dimensional space. And vector u, we'll say, lands over there. And that's its head over there. And these vectors are separated by an angle, call it angle theta. That's literally just, if you were to take two pens, right now I have two pens in my hand, and hold the two tips together, and the two angles, the angle that's made between the two body of the pen, the two pens, that's what theta is. That's all it is, just the angle of separation. So far, I've showed you how to add two vectors together. That's literally just taking the sum of the two components. So like v plus u would be v1 plus u1, comma v2 plus u2, comma v3 plus u3, v3 plus u3. And to subtract them, I would just subtract the components. But how would I multiply them? That's the question we're going to tackle here. So one way to multiply vectors is what we call the dot product. And the way we write that would literally just be v dotted with u. So v dot u. The answer to this would be the dot product of v and u. And the way we calculate a dot product is, pay attention to my color scheme here. It should hopefully make this a little bit clearer to you. Would just be v1 times u1 plus v2 times u2, v2 times u2 plus, oh, I apologize, that's just my house phone. Give it just 1 second to stop ringing. All right, there you go. Plus v3 times u3. See, all I did was just find the product of the x components, v1, u1, and add on the product of the y components, and then add on the product of the z components, v3 times u3. Hopefully my color scheme made that obvious to you. Now there's another way we can actually calculate the dot product of two vectors, and hopefully you remember what it means to take the magnitude of the vector. Like the magnitude of v would be, the length of v would be the square root of v1 squared plus v2 squared plus v3 squared. So to find v dot u, I would have to find, the magnitude of v times the magnitude of u. Now this is key here, multiplied by the cosine of the angle between them. So now, hopefully this definition, just by tacking on that other version of the dot product, gives you more of an appreciation for it. we can use the dot product to calculate the angle between two vectors. See this angle over here? We could use the dot product and find the angle between those two vectors. I could actually, if I wanted to, I could solve for what cosine theta is by dividing the dot product by the product of the magnitudes of each vector. So let's actually do an example. Let's let vector v be 4, 3, 1. These are its x, y, and z components, so it would be 4 along the x-axis. Wow, this actually is kind of accurate. 4 along the x-axis, 3 along the y, and 1 along the z. And if I was trying to let this kind of reflect our diagram below, then I would let u be something like, I don't know, let's say -1, because it looks like it's a little slanted, so it may be along the negative x-axis. Then say -4, maybe. And then probably a +1, because they seem to be the same elevation above the xy plane. So now, knowing this, calculate the angle theta between vectors v and vector u. Give it a try. Well, to do this, all we're going to do is solve for the dot product, which is just v dot u, which is this business over here, and then divide it by, I don't know what that is, I apologize. Let me just tack on a bracket there. All I would have to do to solve for the angle theta would be to find the dot product and just divide by the magnitude of vector v and vector u. So first off, before we find the dot product, actually no, let's start by finding the dot product. So u dot v, or v dot u, either way, it's commutative. V dot u equals, all right, let's pay attention to our color scheme here. 4 times -1, that's v1 times u1. So 4 multiplied by a -1 by a -1 plus v2 times u2, which is just 3 times -4. This is a multiplication sign. Let me make that a little bit more bold. That's a -4 plus v3 times u3, 1 times 1 plus 1 times 1. And I'm sorry if it seems as if I'm taking a while with my color scheme. I just want to make sure that you understand what I'm doing. Okay, so we get that v dot u equals -4 minus 12 plus 1. This gives you a -16 plus 1, a -15 as our answer for v dot u. Now the magnitude of v, let's find the magnitude of v up here, just to save some room. The square root of 4 squared is a 16, plus 3 squared is a 9, plus 1, this gives us the square root of 26. Vector u, the magnitude of vector u, is given by the square root of -1 squared is 1, plus 16, plus 1 gives you the square root of 18. You don't have to break down the radical if you don't want to. But now we have enough information to solve for cosine theta. Notice, cosine theta is nothing more than v dot u divided by the magnitude of v multiplied by the magnitude of u. See, all I did was just divide this by magnitude of v times the magnitude of u. Now I can actually do the calculation. So I got, for our dot product, -15 divided by magnitude of v is square root 26. Should put that in You know what? Let's do it all in white. Square root of 26 multiplied by the square root of 18. And I could find that the cosine of theta is going to be some really ugly decimal. So I want to find theta by taking the arc cosine of this. Arc cosine. Oh, sorry, no. Arc cosine of negative 15 square root of 26 times 18, square root of 18. Hold on. There we go. And I would find that theta, let me do this real quick, arc cosine, negative 15 square root 26 times square root of 18. Now notice, because of this annoying negative sign here, I get an angle of 133. For my calculator, I get an angle of 133.8978. But I would have to actually subtract this from 180 if I wanted to get this angle right here. So I would actually get 180 minus 133.8978. Or I would get 46.1021. And that would be our angle that we have over here, given that our vectors were these guys. So that's a basic introduction to the dot product. Just get used to using it, get familiarized with it. It's going to come up a lot in this playlist. See you soon.